Hello, my name is CARSTEN, and in this video I'm going to explain what speed and velocity is and what velocity time graphs show. I'm also going to talk about the difference between distance and displacement and what distance time graphs show. Firstly, we are going to discuss distance. Distance is defined as the sum of all movement, regardless of direction. This means that distance is a scalar quantity because it only has a magnitude and is measured in meters. An example of distance is the route a marathon runner takes, as a value which is 26 miles. However, running a distance of 26 miles does not mean that they must run 26 miles away from the starting point. If the athlete were to run 17 miles and then turn around and run the remaining 9 miles, they would still have run a distance of 26 miles, despite not running 26 miles away from the starting point. It does not matter where you traveled from the starting point to the finishing point, it only matters how far you traveled in total. Another example with an object is seen when playing squash. When the ball is hit, it travels 7 meters to hit the wall and a further 7 meters to be returned to the opponent. Despite the ball coming back from the wall and towards its starting point, it still traveled a distance of 14 meters. This is because, regardless of where the ball traveled and regardless of what direction it traveled in, it still moved 14 meters in total. Here is a distance time graph. As you can see, an upwards curve shows the acceleration of a body or object. These next two lines show speed. A shallower gradient shows a more constant speed, while a steeper gradient shows a faster speed. A straight horizontal line shows that an object or person is stationary and not moving. A straight line downwards here shows a constant speed back to the start point. This is because the distance is decreasing on the axis, showing how the object or person is moving back to the start point. Finally, this downwards curve shows deceleration of the object or person. Displacement is a vector quantity because it has both size and direction. The definition of displacement is the straight line distance an object or athlete has traveled in a given direction between the start and the finish point. It's a vector quantity. Like distance, it is also measured in meters. However, displacement is different to distance in that it is not how far it took something to get from start to finish, but it is the distance of a straight line directly from start to finish. For example, as you can see in this diagram, let's say someone has run a marathon, the distance would be 26 miles. However, the distance between the start and finish point could only be 13 miles. This is the displacement. Because displacement is a vector quantity, it does have a direction. So when you measure displacement, you include a direction such as a positive or negative symbol, or north, south, east, west, or sometimes by even using angles. The positive plus symbol is used to show movement to the right, and the negative minus symbol is used to show movement to the left. In this example, you could say that the displacement was 13 miles northwest. However, it is possible for displacement to be zero. For example, when playing squash, the ball is hit and it travels 7 meters to hit the wall and a further 7 meters to be returned to the opponent. Because the ball traveled from its start position and also ended at its start position, it therefore has a displacement value of 0 meters. This is because the distance between the start and finish of the ball's travel route is 0 meters. Ultimately, there is no change in distance. There is an equation to find displacement. Displacement equals final position minus the initial position. Speed describes how quickly a body moves, and it is measured in meters per second. It is a scalar quantity. There is an equation to calculate speed. Distance divided by time. For example, Usain Bolt ran his quickest 100-meter race in 9.58 seconds. To find out his speed, you would do 100 divided by 9.58, which equals 10.4 meters per second. In basketball, the speed of a player is particularly important. For example, during a fast break, a player needs to quickly sprint down the court to score and ultimately to succeed at the game. In some events, such as cycling, you can calculate the speed at different intervals. For example, in a 60-kilometer race, a cyclist's average speed may be calculated for every 1 kilometer which they complete. This is useful so that the athletes can see how they are performing throughout their race. Velocity is how quickly an object or athlete has moved in a given direction, and it is also measured in meters per second. It is a vector quantity because it has both magnitude and direction. The equation to calculate velocity is displacement divided by time. When a sprinter runs a 200-meter race, they must run it in 25 seconds with a displacement of about 124 meters. Therefore, to find the velocity of the athlete, you would do 124 divided by 25, which equals 4.96 meters per second. Another example might be with a basketball during a free throw. For example, a basketball might reach the hoop in 0.78 seconds with a displacement of 6 meters. To find the velocity of the basketball, you would calculate 6 divided by 0.78, which equals 7.7 meters per second. So the basketball is traveling at around 7.7 meters per second when the athlete takes a free throw. On this velocity time graph, a positive line shows acceleration of an object or person. The shallower line shows a slower acceleration, while a steeper line shows a quicker acceleration. When there is a velocity higher than zero, a straight horizontal line shows that an object or person is traveling at a constant speed. A straight line in a negative direction shows deceleration. When there is a velocity below zero, a straight line in a negative direction, like here, this shows an increase in speed in the opposite direction. Similarly, a horizontal line when the velocity is below zero shows a steady speed in the opposite direction. Thank you for watching.